Relative motion. We're going to do in this video one of those problems where a swimmer is trying to swim across a river. The current in the river is going to push him downstream a little bit, and as a result we're going to work all the way backwards to figure out what angle heading he could have taken to get straight across the river. Swimmer can swim at a maximum speed of 2.5 meters per second relative to the water. When they attempt to swim directly across the 30-meter river that is flowing from west to east, they find that they are pushed 15 meters downstream. Let's put some of that information here. So they start here, they try and go straight across, and they end up going here. So it says that the river is 30 meters across, and they ended up 15 meters downstream. Determine the heading they should use to swim directly across the river. Also determine how long it will take them to cross the river. So what I can use this triangle for is to figure out when they tried to swim directly across, what angle did they end up going on, and as a result I can use that in a similar triangle, specifically the one that involves the velocities, to figure out what the velocity of the current in the river is. So tan theta is equal to how far downstream they ended up. If this is theta, then this is my opposite, and this is my adjacent, over 30 meters, my adjacent. Remember, tan, of course, is opposite over adjacent. So the inverse tan of a half, essentially, works out to be 26.6 degrees. So that angle there is 26.6 degrees. Now what we know happened when they tried to go straight across and got pushed down is that their velocity relative to the water, or VOW, would have been 2.5 meters per second directly across the river. And what we also know is that due to the velocity of the water relative to the earth, they got pushed so that they were going on a heading that matches up with this triangle that pushed them that 15 meters downstream. So this works out to be 26.6 degrees. Those two angles are the same. So if I have this, my adjacent side, and I'm missing my opposite side, I can use tan again to determine the speed of the velocity of the water relative to the earth, or the velocity of the current. So it ends up being 2.5 tan 26.6, which I guess is going to be 1.25, yeah. Now if you know recognize that these are similar triangles, you could set up a ratio where you'd say 15 over 30 is equal to VWE divided by 2.5, but if you don't recognize that they're similar triangles, that might be a little more confusing, so it's not worth it. Anyways, it works out to be 1.25 meters per second. With that in hand, then, we can imagine trying to aim yourself upstream so that when the river pushed you back downstream, you ended up going straight. So if you head upstream a little bit, and then the river pushes you back downstream, you end up going straight across. This is the velocity of the object relative to the earth. This is the velocity of the water relative to the earth. And this is the velocity of the object relative to the water. So this is you swimming at 2.5 meters per second. The current pushes you at 1.25 meters per second. And the question is, what angle should you do that at such that VOE ends up pointing straight north, or straight across the river? If we're careful here, we'll recognize that what we have is the opposite and the hypotenuse. So this time we can use sine to find that angle. Sine theta works out to be 1.25 divided by 2.5. And theta there, this actually ends up being a half, so this is one of our special triangles, is going to work out to be exactly 30 degrees. So if you want to go straight across the river, the heading you should use is north 30 degrees towards the west, assuming that the water is pushing you from west to east or pushing you in the east direction. Finally, also determine how long it will take to cross the river. what we can see then is that this is the velocity that's actually going to be getting you across the river. We can find this in a couple ways. We could use trig, or we could use the Pythagorean theorem. I'll just use trig because I think it's pretty easy. This is the adjacent, and we have the hypotenuse. So I'm going to use cos 30 is equal to adjacent over hypotenuse, which works out to be, in this case, well, I don't know my adjacent, that's what I'm trying to find, VOE. My hypotenuse is 2.5, cos 30. So VOE is going to work out to 2.5 cos 30, which happens to be 2.16. We're assuming that you're swimming at a constant speed here, so we can use our uniform motion equation that velocity, or average speed, is equal to distance divided by time, recognizing that the river is 30 meters wide, as stated here. We're interested in the time, and the actual speed that we're going across the river with here is 2.16 meters per second. We can solve for time. Multiply both sides by time, which we can do as long as time doesn't equal 0. And then 2.16 meters per second, time equals 30 meters, dividing both sides by 2.16. Time is left over. And it works out to be 13.9 seconds. So if we want to go straight across the river, we should point ourselves slightly upstream, north 30 degrees west, and if we do that, some of our 2.5 will be used up fighting the current, and so we'll only travel at 2.16 meters per second relative to the Earth, and so it'll take us 13.9 seconds to get across the river.